Memory is a critical component of any computing system, serving as the storage medium where data and instructions are held for processing by the Central Processing Unit, CPU. It is broadly categorized into volatile and non-volatile types, each serving distinct purposes in the operation of a computer. Understanding how memory works is key to grasping how computers manage data efficiently and reliably. Volatile memory is a type of memory that requires a constant supply of power to retain its contents. When the power supply is interrupted or the computer is turned off, the data stored in volatile memory is lost. This type of memory is designed for temporary storage and is optimized for speed, making it ideal for tasks requiring rapid access to data. The most common form of volatile memory is random access memory, or RAM. RAM plays a central role in the operation of a computer, acting as a workspace for the CPU. When a computer runs a program or processes data, the necessary instructions and information are loaded into RAM from the computer's permanent storage, such as a hard drive or solid-state drive. This is because accessing data in RAM is significantly faster than retrieving it from permanent storage. RAM allows the CPU to quickly read and write data needed for active processes, enabling smooth and efficient performance. For example, when editing a document, the text and formatting instructions are held in RAM while the application is in use. However, because RAM is volatile, any unsaved work is lost if the computer is turned off or crashes. In contrast, non-volatile memory retains its contents even when the power is turned off, making it suitable for long-term storage of critical information. One key example of non-volatile memory is read-only memory, or ROM. ROM is used to store firmware, the low-level software that provides essential instructions for the hardware to initialize and operate. Unlike RAM, the data stored in ROM is typically permanent and cannot be modified under normal circumstances. This ensures that vital instructions, such as those needed to start up the computer and load the operating system, remain intact regardless of power interruptions. ROM works by storing data in a way that does not rely on electrical power to maintain the information. The contents of ROM are written during the manufacturing process and are designed to be both durable and reliable. When a computer is powered on, the CPU accesses the instructions stored in ROM to perform initial checks and load the necessary components of the system. For example, the basic input/output system, BIOS, or its modern equivalent, the Unified Extensible Firmware Interface, UEFI, is stored in ROM, ensuring that the computer can boot up and operate as intended. The interplay between volatile and non-volatile memory ensures that a computer can operate efficiently and reliably. RAM provides the speed and flexibility required for active processing, while ROM offers the stability and permanence needed for critical system functions. Together, these types of memory enable computers to perform complex tasks while maintaining the essential foundations of operation, demonstrating the importance of memory in modern computing.